Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over problems 11 to 15 of the August 2015 Algebra 1 Common Core New York Regents exam. All right, so let's take a look at number 11. It reads, which representations are functions? So we have a tabular representation here, a graphical representation, a set of ordered pairs, and also a linear representation. Okay, this is algebraic. Now, which of these represents a function? Now, before we select the right options, let's just do a real quick recollection of how a representation fails to qualify as a function. Now, if you're given a table of values, like in option 1, what you're looking for is for repetitions in the x's. Okay, so in order for it to be a function, you need to have no repetitions with the x's. Okay, so your inputs have to be unique without any repetitions. How about a graph? If you're given a graph, your graph has to pass the vertical line test. Okay, so if you draw a vertical line through every point in the domain of the graph, the vertical line has to intersect exactly once. Okay, so if it intersects exactly once, it passes the vertical line test. For a set of ordered pairs, the test here is very similar to the tabular representation. You look at the x's and you want to make sure that there are no repetitions. Okay, no repetitions on the with the x's, and then it's a function. Okay, and then when you have an algebraic equation, you just want to look at the output variable, in this case is a y, and make sure that it has an odd power. Okay, so y has an odd power. If it has an odd power, then it is a function. But if the power is even, then it's not a function. Okay, so let's keep that in mind. All right, so let's go ahead and apply these facts to these four cases. Case number 1, we have, this is a tabular representation. Let's look at the x's and see if there are any repetitions. You have an x here, you have a 2 here, and you also have a 2 here. Well, there are repetitions in the x's, so what does that mean? This is not a function because you're assigning one input to two distinct outputs, namely 6 and -6. Okay? Option 2, you look at the x's. All right, this is xy, xy, xy. Okay, look at all the x's. So the first ordered pair, you have 1 for the x. Do you have another 1? No, that's good. The next ordered pair, you have a 2 for the x. You have another 2. No, that's good. This one, you have a 3 for the x. Do you have another 3? Nope, that's good. The next ordered pair, you have a 4. You have another 4. Nope, that's good. 5, another 5. Nope, that's good. 6, another 6. Nope, that's good. And then this 7 is unique. So this is a function. Okay, this is in fact a function. In this representation for 2 is a set of ordered pairs. Okay, now 3, this is a graph. And then all we do is we take our vertical line and do the vertical line test. Okay, so we just draw a vertical line and see, does the graph intersect more than once at any point in the domain? If it does, what does that mean? The graph is not a function. Okay, so do you see how this fails the vertical line test? It intersects 1, 2. This is not a function because this unique input here is being assigned to 2 distinct outputs. Okay, so this graph fails the vertical line test, hence it is not a function. Okay, all right, and then for option 4, y has a power of 1, which is even. This is your algebraic representation. It has a power of 1, which is even. Guess what? It is a function. Had it been that y had a power of 4 or 2, an even power, then it will not be a function. Okay? So we're asked which ones are functions. So option 2 is a function, and option 4 is a function also. So our correct answer is option number 2. Okay, let's take a look at number 12. It reads, if f of x equals the square root of 2x plus 3 over 6x minus 5, then f of negative 1/2 is. So we're basically evaluating a function at a point. So let's go ahead and rewrite the function. We have f of x. I'm going to color code my inputs so we can keep track of where our assigned input value is going to be substituted into. Okay, so 2x plus 3, all right, divided by 6x minus 5. Okay, all right, so what does f of 1/2 mean? What does this mean, f of 1/2? F of 1/2 simply means that you want to substitute 1/2 for everywhere you have the x's in this function. Okay, so let's go ahead and do that. So we have square root of 2 times, instead of x, we're going to have 1 over 2. All right, and the operation is times plus 3. Now you have to be careful here. You're dividing the entire numerator, not just the radicand. The entire numerator is being divided by 6 times 1 over 2 minus 5. Okay? All right. So if you look at this, you might get a little bit intimidated and think it's very complicated. Well, it's not really complicated. From here on out, we're just using the order of operations. The tricky part is resolving this product here between an integer and a fraction. And in the denominator, you have the product of an integer and a fraction right here. The easiest way to do this is expressing the integer as a fraction also. Okay, remember every integer can be expressed as a rational term. Okay, so to make this easy, we just divide this by 1 and divide that by 1. All right, now how do you multiply fractions? Numerator multiply with the numerator and denominator with denominator. Okay, so we're just going to have the square root of 2 times 1 is 2 over 1 times 2 is 2 plus 3 divided by, downstairs, 6 times 1 is 6 over 1 times 2 is 2 minus 5. Okay, let's go ahead and simplify further. We're going to have 2 divided by 2 is 1, so the square root of 1 plus 3. 1 plus 3 divided by 6 divided by 2 is 3 minus 5. Okay, simplify further. 1 plus 3 is 4, so the square root of 4 divided by 3 minus 5 is negative 2. Okay, now let's go ahead and find the square root of 4. The square root of 4 is 2 divided by negative 2. Now what is positive 2 divided by negative 2? Anytime you divide numbers with different signs, remember the sign is always negative. So you want to be careful here. 2 divided by 2 is 1. All right, so your correct answer is option number 3. All right, let's take a look at number 13. 13 reads, the zeros of the function f of x equals 3x squared minus 3x minus 6 are. So what are zeros of a function? Zeros of a function are values that when you evaluate the function at those values, you get 0. Okay, there are 2 ways you can do this problem. You can work backwards by substituting values into this function and seeing which set of solutions gives 0 for both answers. or you can solve the equation. All right, the easiest approach here that I'll advise is for you to go ahead and solve this equation so you don't make any, because the other method, when you're substituting, it takes too much time and you run the risk of making computational errors when you're evaluating the function at the prospective zeros. Okay, so what we're going to do is solve the equation. To find the zero, we're going to set the function equal to what? We want to know when the function is equal to 0. That's why the zeros is here, okay? So you set it equal to 0, and we'll ask ourselves, can I reduce this equation by a constant? Is there a GCF happening here? And the answer is yes. Reducing quadratic functions or any functions in general by the GCF really helps simplify the factorization process. So if at any point in time you can reduce the entire equation by a constant, I'll go ahead and do that. All right, so the GCF here is 3. So I can factor out 3 from the entire equation or simply divide both sides by 3. Okay, but let me factor out 3 here. So if I factor out 3, I have x squared minus 3, x squared minus x minus 2 equals 0. Remember, anytime you factor out a constant, it is as though you are dividing by that GCF you factored out. Okay? Next thing to do is divide by that constant, divide both sides by 3. And we now have a simplified quadratic equation, x squared minus x minus 2 equals 0. Had it been you forgot to execute this step, you could still get the same answer, but you might just have to do more reduction in your factored form. Okay. All right. So now we're going to factor this using the x game. AC goes on top, -2, and B is -1. Okay. In this problem, A is 1, B is -1, the coefficient of x, and C is -2, the constant. Okay, so we multiply A, so you get -2, and B is -1. Now, what two numbers multiply to give you -2 and add to give you -1? The two values are -2 times 1. So -2 times 1 is -2, -2 plus 1 is -1. Okay, so our factored state will be x minus 2 times x plus 1. Now, does this mean that our zeros are -2 and +1, as indicated in option number 2? The answer is no. We're not done yet. We have to apply one more process, the zero product property, to determine what the zeros are. So to do that, we set both factors to 0, and you isolate x. Okay, so in the left side, to isolate x, you add 2 to both sides, and that yields x equals +2. That's the first 0, and then you subtract 1 from both sides, and you get x equals -1. That's the second 0. Okay, so your zeros are 2 and -1. All right, so correct answer is option number 4. All right, let's take a look at problem number 14. It says, which recursively defined function has a first term equal to 10 and a common difference of 4? Okay, so if you think of first term, basically you have a function where when you input the first term, you get an output of 10. So first term is going to be f of 1. Let's write this down. First term is going to be f of 1. 1 means the position, okay? 1 is for first. So f of 1 is equal to what? 10. F of 1 is equal to 10. So with this equation in mind, we can quickly eliminate options 2 and 4, since those ones have 4 as a first term, which is not consistent with what's indicated in the problem. Now, it goes further to say the common difference of 4. This word common difference, what does that mean? Anytime you see common difference, you think about addition. Okay? Common difference of 4 means that you add 4 every time. Okay? Add 4 every time. That's what the common difference means. When you add 4 every time, when you subtract a term from the previous term, you end up with 4. Okay? So common difference, when you hear common difference, you think about adding and subtracting. Okay? When you hear the word common ratio, you think about multiplying or dividing. Okay? If you look at option 3, you see 4 times the previous term. This is a common ratio example. But option 1, you have plus 4. This is a common difference. Okay? So our answer is option number 1, because the first term is 10, and this plus 4 indicates that subsequent terms of the recursively defined function grows by 4, or you have a common difference of 4. This one here has a common ratio of 4, which is not what we want. All right? So our answer is option number 1. All right, let's go ahead and take a look at problem number 15, the last one in this installment. It says, firing a piece of pottery in a kiln takes place at different temperatures for different amounts of time. The graph below shows the temperature of a kiln while firing a piece of pottery after the kiln is preheated to 200 degrees Fahrenheit. And the question is, during which time interval did the temperature in the kiln show the greatest average rate of change? Okay, so we're looking for the average rate of change here. So first thing to do is you want to recall how to compare the magnitude of the slope of lines based on their degree of inclination. Okay, if you start from a vertical line has a slope of it could be positive or negative infinity. Let's say we're starting from a slope of infinity. Think about infinity as a very big number. Okay, if you go from positive infinity, well, I could indicate positive infinity by using the direction there. And then the line starts to go from vertical all the way to horizontal. Guess what's happening? If you go from vertical to horizontal in this direction, in the clockwise direction, the slope is decreasing. Okay, because the slope of a horizontal line is 0. If you go from big to 0, what's happening? Are you going up or down? You're going down. Okay, so if you're going in this direction, the slope is decreasing. Okay, so if the line is going from left to right and it's going upwards from left to right, the more slanted the line is, the bigger the slope. The less slanted it is, or closer to 0 or horizontal, the smaller the slope. Okay, so this line right here has a greater slope than this line right here. Okay, and this one has a greater slope than this one right here because it slants more and is increasing from left to right. All right, okay, now why are we talking about slope of lines? Well, it is because this thing we're asked to find here, average rate of change, that is simply the slope of a secant line. Okay, I'm going to call average rate of change AROC. That is the slope of a secant line. Okay, of a secant line. A secant line is basically a line that goes through 2 points on a graph. Okay, if you look at this situation here, we have 1, 2, 3, 4, 5 secant lines. 1, 2, 3, 4, 5. Okay, let me number them. So this is secant line 1. You have 1 here. This is 2. This is 3. This is 4. This is 5. We have 5 intervals, which means we can have 5 secant lines, okay? So this is the first secant line right there. We have another secant line right here. There, we have another secant line here, a secant line here, and a secant line there. Okay? Now, if you look at what we just sketched, can we eliminate some secant lines? Because we don't want to calculate the value of the secant line for all 5 intervals if we can simplify our task. If you look at interval 4 and 5, how do they compare to the lines in 1, 2, and 3? Are they less slanted than those 2 lines? Absolutely, since interval 4 and 5 have a slant that's less than 1, 2, and 3, that means that they have a smaller slope, which means they have a smaller average rate of change. Okay, so since they both have a smaller average rate of change, we're going to eliminate those intervals. So interval 4 goes from 2.5 to, wait, let me see, interval 4 goes from 2.5, somewhere here, all the way to 5. And then interval 5 goes from 5 all the way to 8. Okay, so let's look at the options. 2.5 to 5, eliminate that. And then 5 to 8, eliminate that. All right, now, let's, oh, snap, what did I do? Eliminate 3 and 4. Let's go back to the graph and see which ones we want to focus our energy on. So we are left with 2 options. Okay, we're left with 0 to 1, 0 to 1, or 1 to 1.5. So we don't even have to bother with interval number 3. All we are just focusing on is interval 1 and interval 2. Now, which one is more slanted than the other? Is interval 1 more slanted than interval 2, or interval 2 more slanted than interval 1? Whichever one is more slanted, that's the correct answer. But in this case, it's very hard to tell. Okay, it's hard to tell which one is more steeper or more slanted. So what are we going to do? Well, we have to find the exact value of the average rate of change for both intervals in order to be able to correctly compare them. Okay, so how do we do that? We are going to make use of our slope formula. The slope formula, m, so the average rate of change over an interval from x1, y1, all the way to x2, y2. You know what the slope formula is? It's rise over run, y2 minus y1 over x2 minus x1. Okay, so the average rate of change is basically the slope. So let's go ahead and do that. Okay, so let's start with interval number 1. From interval 1, this point here has an x-coordinate of 0 and a y-coordinate of what? Since we're going by 400s, half of that is 200. Okay? All right, so let's go ahead and find the slope of interval 1. Interval 1, we're going from 0. We're looking, we're looking for the slope of the secant line that goes through 0 to 100, the first point, and the second point, 1, 700. Okay, that's what we're looking for. So the slope of interval 1 is going to be what? Let's label it x1, y1, x2, y2. What's the formula for slope? Don't forget, rise, y2 minus y1 over run, x2 minus x1. So that's what we're going to use to compute the slope here. All right, so let's go ahead and do it. So y2 is 700 minus y1, which is 200. That is the rise divided by the run. X2 is 1 minus x1, which is 0. Okay, so we're looking for the slope of a secant line on this interval right here from 0 to 1. How steep is this line? 700 minus 200 is 500. 1 minus 0 is 1. The value of the slope of the secant line, or the average rate of change from 0 to 1, is 500. Okay? Now let's take a look at the next one, interval 2. Interval 2 is from 1 to 1.5. We don't care about interval 3 since it's not an option in the problem. So for interval 2, we're going from where to where? We're going from 1 comma 700 to let's see, what's the second point? 1.5 comma 900. 1.5 comma 900. All right, so all I did is I took a look at these 2 points here. This is interval 2, so you look at this point and this point. We're focusing on this the slope of this secant line right here through these 2 points. Okay? All right, so we have our x1, y1, x2, y2. Slope of the secant line through interval 2 is going to be y2, 900, minus y1, 700, divided by x2, 1.5, minus x1, 1. All right? 900 divided by, 900 minus 700 is 200. 200 over 1.5 minus 1 is 0.5. You can do this with your calculator, or you can change this into a fraction, or you can just adjust the decimal points. Okay, so if I adjust the decimal points, I'm going to have, I'll move it one place to the back, right here, and then upstairs 1 place to the back. Put a 0 in here, so you have, this is the same thing as 2,000 divided by 5. Okay, so 5 goes here once, 5 goes into 2400. 400 is the average rate of change for interval number 2. Okay, remember, if you don't like this method, you can divide with your calculator or change this into a fraction, and then you drop change flip, you still get 400. Okay, so the question is, which is greater? Interval 1 is greater from 0 to 1 hour. So our answer is option number 1. Thanks so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this video helpful to you, do give us a thumbs up. We appreciate a positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series. If you have any questions about any concepts on the Algebra 1 Common Core Regents exam, just place your question in the comments section below, and we'll be glad to assist you as soon as possible. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day.